What if I told you that everything we thought we knew about the king of planets, Jupiter, was wrong? For decades, scientists have debated a simple question. What lies at the very heart of this gas giant? Is it a solid, dense core, like a rocky planet buried deep within? Or is there no core at all, just gas getting denser and denser all the way to the center? For years, these two competing ideas dominated our understanding of how giant planets are born. But now, thanks to a lone spacecraft braving Jupiter's punishing radiation, a third, mind-bending possibility has emerged. The answer, it turns out, is neither. Welcome to the era of the fuzzy core. I'm talking about NASA's Juno spacecraft. For 8 incredible years, this probe has been dancing with the giant, swooping closer than any mission before it, mapping its gravity and magnetic fields with unprecedented precision. And the data it has sent back is nothing short of revolutionary. It's forcing us to rip up the old textbooks and start a new chapter in planetary science. Juno's instruments are so sensitive they can detect tiny wobbles in Jupiter's gravity as the spacecraft flies by. These wobbles are like a planetary-scale MRI, allowing scientists to peer through the thick clouds and infer what's happening deep inside. What they found has sent shockwaves through the astronomical community. The evidence points to a core that isn't a neat, solid ball. Instead, it seems to be a dilute, or fuzzy, mixture of heavy elements like rock and ice, blended with hydrogen and helium, stretching out to nearly half of Jupiter's radius. Imagine a cosmic slushy instead of a hard pit. This isn't just a minor detail. It completely overturns our models of how Jupiter formed. The old theories couldn't explain this strange, extended core. It suggests a far more chaotic and violent past for Jupiter than we ever imagined. So, how could a core get so fuzzy? One leading idea is that early in its history, Jupiter was struck by another massive baby planet, a protoplanet. This colossal impact, happening billions of years ago, would have been powerful enough to shatter Jupiter's original dense core, scattering its contents and mixing them with the lighter gases of the deep interior. It's a dramatic story of planetary collision that would have fundamentally altered Jupiter's evolution from the very beginning. This giant impact hypothesis elegantly explains why the core isn't a compact sphere but a sprawling, diluted region. This discovery has huge implications beyond just Jupiter. Jupiter is our archetypal gas giant. It's the model we use to understand the hundreds of similar giant planets we've discovered orbiting other stars. If our fundamental understanding of Jupiter's interior is wrong, it means our understanding of all these exoplanets might be wrong, too. The fuzzy core concept isn't just a quirky feature of one planet. It could be a common outcome for how giant planets form across the universe. Are all gas giants born from such violent collisions? Do they all have these strange, diluted cores? Juno has opened up a whole new line of inquiry, and it doesn't stop with the core. This fuzzy interior also helps explain another of Jupiter's great mysteries, its bizarre magnetic field. Jupiter's magnetic field is a beast, 20,000 times stronger than Earth's, but it's also weirdly structured. Unlike Earth's field, which is mostly concentrated at the poles, Jupiter's is lopsided, with a strong spot in the northern hemisphere and a weaker, more spread-out field in the south. For years, scientists struggled to model this, but a fuzzy core provides a potential answer. The dynamo engine that generates a planet's magnetic field is created by the motion of conductive fluids. In Jupiter, this is liquid metallic hydrogen. The fuzzy core changes where and how this dynamo operates. With the heavy elements mixed into the upper layers of the core region, it could be creating a more complex layered dynamo, generating the strange, asymmetric magnetic field we observe. The pieces are starting to fit together in a new and exciting way. Let's talk about how Juno even figured this out. The key is gravity. As Juno orbits Jupiter, it's pulled by the planet's gravitational field. If Jupiter were a perfect, uniform sphere, this pull would be perfectly consistent. But it's not. It's a spinning, slightly squashed ball of fluid with different densities at different depths. By precisely measuring the tiny changes in Juno's velocity down 2 micrometers per second, scientists can map out these subtle variations in the gravity field. These measurements, known as gravity moments, are the fingerprints of the planet's internal structure. The data Juno has collected is so precise that it ruled out both the solid core model and the no-core model. Only a model with a large, diluted, fuzzy core could match the gravitational signature Juno was detecting. It's an incredible feat of engineering and data analysis. This ongoing mission continues to reshape our cosmic backyard. Every 53 days, Juno performs another close flyby, gathering more data, refining our models, and peeling back another layer of Jupiter's secrets. We're learning about the deep atmospheric winds, the polar cyclones that rage in beautiful geometric patterns, and the powerful auroras at its poles. But the discovery of the fuzzy core stands out as perhaps its most profound legacy. It challenges our most basic assumptions and shows us that even the planets we thought we knew best can still hold deep surprises. It reminds us that the universe is often more complex, more chaotic, and far more interesting than our neat theories predict. The story of Jupiter is still being written, and Juno is our pen. What other secrets does the giant hold? Could this fuzzy core be the key to understanding planet formation everywhere? These are the questions that will drive planetary science for years to come, all thanks to a daring mission that went to take a closer look at the king of planets and found a puzzle at its very heart. It's a testament to human curiosity and our relentless drive to understand our place in the cosmos. Thank you so much for joining me on this journey to the heart of Jupiter. If you found this as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the wonders of our universe. Let me know in the comments what you think about the fuzzy core. See you in the next video.